So, hi Goran, welcome back to the show.
Hi, Adam. It's a pleasure to talk to you. Like always funny
Yeah,
and always a lot of technical stuff.
yeah.
So
And Opacic is your last name, right?
yes, exactly.
Perfect. The last time you mentioned that you have a company and it runs on AWS and there's something to do with
Yeah, yes.
mobile. So, what are you doing exactly? And what is it a company? So, what is it?
So there's a field in technology in business called Salesforce automation. So everyone who's doing anything in the field has
Mhm.
to have some kind of a mobile device. It was like a laptop or Windows Mobile, or now it's iPhone or Android phone or device. So people are taking orders, making some like measurements, taking counts of something, like reading some devices or anything like. So anyone can pick some kind of data from the field, and then we track them and do some transfer that data to other companies and stuff like that. So basically it's like it's an IoT on one side, but then with all this mobile stuff, these devices are super smart. It's a super big computer that you have on mobile devices. Things that makes these things hard is like the internet is not that good.
Mhm.
Like it's 2021 and still there are many black holes. So these applications need to work completely offline. Even if you don't have internet, you have to work with it. So there's no rest
Mhm.
call to do. So if you are in some like a nuclear plant or something, so you need to collect data. So everything has to be collected even offline and then synchronized with the backend. So
Mhm.
that's what we do. Like that's it in general. So, but then like on the backend side, it's a lot of data exchange with other companies and other,
Mhm.
whatever you collect, you need to forward to someone. So there's a lot of different protocols like EDI, like typical REST interfaces, and also a huge database and analytics and stuff like that. So whatever software you do, like after 15 years, it's a giant software that does more than you ever expected that it will do. Like because you just add stuff.
Mhm.
So like it's also has some kind of ERP feeling. Sometimes,
Yeah.
and whatever you do, and you end up with some giant software
Mhm. But
after 15 years. You have to quit at some point of time. Like don't build software for 15 years.
what would be the use case? So, what I would have to have for a business, to be able to buy your stuff.
So, for example, you are selling coffee. You're a coffee company, and then
Very
selling
good.
coffee. You need to visit all the coffee shops and offer them coffee and ask them, okay, do you want our coffee? And if they like, then they will order. If they don't like, then you need to collect information why they don't want it. So, and then also I'm monitoring my employees, like how much time did they spend between two shops, and is it optimal? Can I make an optimal route for them and stuff
Okay.
like that? I mean, it's whatever you do on mobile phones, but for businesses, like no Facebook, no stuff like that. It's kind of boring world, with this business world, because many things are changing really slowly. There are many protocols that were there like before these
Mhm.
new stuff like REST and JSON, like especially the EDI.
Mhm.
And then when you see that it just works and
Mhm.
companies are already connected, it's so hard to move from that to something like better or newer or something. Even like moving to TLS 1.1 or 1.2 was so hard,
Yeah,
because
especially one to
businesses just
two. So we had we had some memory leaks and stuff. This was crazy.
and also like in businesses, like they really like this feeling of having a fixed IP address. That's security. I have
Yeah.
a fixed IP address with a firewall, and you have to give me a fixed IP address, and then we will allow each other's traffic. And then that's something that really changed with the cloud. Like you need to have security and protocols implemented. Like no, there's no trust there's no easy trust. You need to check all the time and generate tokens and then give rights and back and forth. So things need to be like more complicated for the security we need. But with these businesses, it's almost impossible. We will like be in 2050 and they will still use the same old protocols. And that's super heavy.
How you got the idea for your product? Was it a project or product? So
I worked in one company as an IT consultant 20 years ago, and then they had a problem that everyone was collecting some paper forms, like from the field. Why is the shelf empty in the shop? Like which products are out of stock and stuff like that. So they were collecting these things like on paper, and then when they go back to the company, they type it in an Excel sheet, and then from Excel sheets they get like some kind of reports. And the problem is like when you have something which is out of stock or some problem in the field, you need immediate reaction. Like if you need 5 days to collect data, then it's like irrelevant. So their whole work was completely irrelevant. And then I got then I saw this Palm device. The old Palm devices with green screens, and then it was so easy to develop simple application and forms for it. I was really impressed, So there was no internet internet connection on them, but you were able to connect them to a dock when you go back to a company or your. So you just synchronize the database, and then the database can be sent to the central location, and then you just collect data, and that's. And from that things changed, but what it's not the technical things that was really important in that process. The thing was like when that company told me, look, we have a problem. We don't have a budget in IT for this. Can you sell this as a service to us, like an expense? So as an OpEx. And I said, okay, but that's a software. And then I realized, okay. Not only I will sell you the software on monthly basis, I will also rent you devices and everything. And that click was that moment was when I realized that we are actually selling service. So I should sell them complete package, on as a service and charge them on monthly basis. And then everything started. I was able to sell software to marketing and sales without even talking to IT departments, like just because I'm selling a service. So that was more important shift than that technological shift from my perspective. From that point of time, I never sold my software. It's not running on premise anywhere. Like for a couple of years, we were running this server side on different providers. The last one was Hetzner, and then after the Hetzner, we had a short episode with Microsoft Azure. It didn't go well. and then we said, okay, let's go to AWS, and with some ups and downs, it's pretty much like a super great story,
And Hetzner worked well for you?
Hetzner is like a magic. I don't know how do they manage to get such good servers for that amount of money. Like it's impressive, and like flawless. So if you do some stuff on premise, just go there. This is not marketing. I'm not paid for this. I will always say they're just great. Now they're running in some operations in US, so you can have Hetzner in US now. So it's amazing, Dell PowerEdge servers like with so much RAM and disk for that money. That's impossible, like 5-6 years ago, I was super happy with them. And, you can easily get and provision big machines with them. And, but the problem with all these things is that you have to manage these things by yourself,
Yeah,
so,
exactly.
And at that time I was managing like a startup manager. I was also doing a lot of technical stuff, especially MySQL, and we were running Percona cluster at that time. So, it's hard. If something is down, you have to really, really understand what's going on. And you're going deeper and deeper and deeper in these technologies, and you just can't cope with everything,
Yeah, exactly.
So that's and Hetzner is now trying to get closer to what AWS is doing and others, like, but it's not easy, that they're still like closer to bare metal than to some abstract services like in internet. But you can provision stuff like with the API there, so you should be. I don't know if there is a Terraform provider for them, but you should be able to do some stuff with the infrastructure as a code also with them. But still,
exactly.
it's a bare metal.
So even at the airhacks, I always said if you would really like to just have OpenShift or whatever, you don't have to run it on cloud. You can buy some headsnap boxes, install your cloud, and you have your small cloud, and it worked perfectly. And it is going even to be really cost effective and cheap.
Yeah, exactly. I mean, if your first thing, if the first thing you think about is money, okay, and you don't care about the hours you have to spend on learning stuff,
exactly,
okay, then that is fine. I mean, I still like that feeling of having access to like this KVM interface, so I can see the machine booting. I mean, that's great feeling. Like after all these years in AWS, I kind of miss that. Like I don't know what's going on with lambdas, and I would really like to see that stuff booting, but it's happening so fast, so don't log that.
The AWS should sell screensavers with booting machines, so they can actually.
I mean, that matrix feeling that we are coders, we see some stuff on green letters on the screen, so that feeling, you don't get that with these new technologies. Like. It's you don't have access to terminal. That's that's a pity. So
well,
but still,
not entirely true, right? Because with EC2, I've used EC2 machines, so you can absolutely connect.
Yeah, you are still using EC2. Yeah, you are still using
no,
EC2.
I'm for instance, I'm using EC2 for Graal VM compilation. Yes, I'm using EC2 for sometimes, as a code pipeline job, to automate things, to build the stuff. And as Bastion hosts to try things out, you can launch the EC2, but you then have to access. And what I use is the system manager, how it's called, session manager, I think. So you can without SSH key you can connect, and then you see actually the terminal, and this is very bare metal, right?
Yeah, but the goal should be like not to have any EC2 instances. Like that's. I mean, it's good for if you want to solve a problem right now. Mm-hmm. But with AWS, you should always look for the latest thing and see, okay, this is the future. I have to be there,
Exactly.
Because they don't miss the point. For all these years, they didn't miss the point. Like they really have the point about serverless and stuff like that. It proved in many ways in what we did is that there's no point of making your own cloud inside the cloud, managing your own servers inside the managed environment. So like
no point. This is even crazy. What it reminds me, back then where people installed Spring on Whitefly, and I say, okay, now we have two dependency injections. No, and now what? Why? And this is exactly like you would run your own cloud inside a cloud. It's okay. Now you have two clouds. You have to manage both. What's the point? Either use this first cloud or the AWS.
Exactly. And when you see people installing Kubernetes on AWS or anywhere, that's the exact thing that's happening. They're making their own cloud inside the cloud.
Yeah.
They're defining their own machines, and inside these machines something will run. Yeah. Okay. The goal is to have. I have this kind of a workload. This function does this. I want it to be deployed in the best way it matches its performance, requirements, stuff like that. So you can define per function what you want and what kind of capacity, what kind of resources you want, what kind of permissions. It can scale independently from other stuff. That's something that from the point of the final future product, that's something that I really want. I don't want to define servers, and then one function could influence another function, can really kill another one, get it to the state of out of memory or out of many different resources. Things have to be independent so they can easily scale. Just like with the microservices, but then you have to go further. Like every single execution needs to be independent in a way.
So that's interesting point.
It's a hard goal. It's a hard goal. It's not easy. It's just
I think for me it is easy. It is not hard. This is interesting. So, my perspective. You said go serverless. This is also my opinion. But where we are coming from, as I'm coming from microprofile and Java EE, and for me it was always serverless. So what you describe right now, this is exactly the same feeling I had with application servers. Now I have with serverless. Why that? Back then, a few years ago, I coached a startup. And say, okay, pick Whitefly. It was before Quarkus, and just focus on business. Ignore the entire plumbing. Use just a subset, whatever you need. Just use and write very simple code. And I got feedback from the startup. It's crazy. So we are highly productive. So we write only a little code, and it is very fast. So why it is so fast? It's like this is so fast because you write simple code and you don't try to optimize. And if you know what they are doing from the business perspective, it will execute fast. Exactly the same experience I have actually with Lambda. So if you build your Lambda and you don't care about the optimizations too much first, and you just give it a little bit CPU, it will run surprisingly fast. So with Java. So I'm just talking about Java. I'm just using Java on AWS. So now, what we are doing in my current projects is really crazy. So we are actually picking a mid-range microservice. It could be, let's say, 10 JAX-RS endpoints with dependency injection and everything, and run it on Lambda. So with Quarkus, it works perfectly. So what happens technically, we have either a load balancer or HTTP API gateway, or in enterprise companies, REST API gateway. So if you pick the AWS REST API gateway, this is the older one, but it's sometimes required if you need to know I don't know whether you need it, but some of my clients need it, like the VPC integration. So the Lambda should be only visible from within the VPC, and be accessible via direct connect, like direct line to AWS.
Yes, exactly.
Yeah, and the HTTP API gateway is nice, or sometimes load balancer is nice. It really depends for what. And this is the basic architecture. Now, in my one of my current projects, we already have 300 Java classes. The project is going to be actually a large, and we have only one Lambda. The cool story is we're running with 2 gigs of RAM just because of the CPU. We need far less. We can test everything locally, so we can start Quarkus locally, and it executes without any local stack. It just executes as a microprofile runtime.
But you said you have one Lambda, or you have like Lambda per function?
One Lambda. One Lambda.
Does it scale like the different things? Like different things should scale independently. Like that.
Yeah, you should. But listen, what happens now? So in our case, so first we are highly productive. The developers can use locally it looks like Whitefly. It doesn't matter locally. You say Quarkus compile Quarkus.dev and it runs locally. There is no Lambda in place. It's just stock microprofile. Then we use Java CDK on AWS code pipeline and code deploy on every push fully system tests. So we push it to AWS. Then unit tests are created and the Lambda is automatically installed. Now the cold start takes 3 seconds, and any subsequent invocation is, I would say, under 50 milliseconds. So it performs great. There is no need for modularization. We will get maybe 2 or 3 other Lambdas because they make sense. But for me, such Lambdas is a great endpoint microservice, right? It is the entry point to the serverless world, because we have to serve an API to the outside world, right? So now the persistence, we use S3. I was curious. I said, okay, just start with S3 because it's interesting. I was really, a little bit cautious with the latency because I said, okay, maybe it's going to be too slow. Now, the latency is great. At like 20 milliseconds, we can access, the S3 from this Lambda. So, from the architecture, we getting, the Java objects from via microprofile and JSON-B, and we are able to store them more or less directly in S3. So it is actually simpler than with a database in this particular project. And So the interesting part, so we are using Lambda, yes, but the only difference is that instead of running on application server or whatever, we just say, to AWS, just we would like to have Java 11. So this is actually what you have to do in CDK. And the entire infrastructure with permissions, S3 bucket, and so forth, is written with CDK v2 with Java completely in Maven. So we have actually a self-contained runtime, and it feels more productive than even back then, and it will scale like crazy, because the difference is, if you think about this, back then with application servers, we had one application server with multiple threads. Now the application server is AWS, is actually the Lambda execution environment, and one Lambda is a process. So if you have 10 parallel requests, we get 10 processes running side by side, and each of the processes will get one CPU and 2 gigs of RAM. Yeah. So that's the difference to before. It's not like we have.
If you compare that to a Microsoft solution or Google solution, they allow 2 requests to run in parallel on a single serverless instance, which is what we have today in our application servers. But with AWS, you don't have that, and sometimes people see that as a restriction. But when you see how easy and fast it is, and you say, well, I have a dedicated resource per request. That's amazing, and then you start appreciating that, because you don't have no one can kill your process or destroy other requests. Heavy requests cannot kill you. So, but let me give you another idea. You can have the same code that you built, that zip one or jar or something that you built for that Lambda in. But then with the CDK, you can create different Lambdas as resources.
But why?
That use the same code.
Yeah, okay? No.
So, but let me give you an example. So, for example, one Lambda can do only writes, for example, and another one is only reads. Okay. And you can say, I will, in API gateway, I will set that writes can be done only 10 requests per second maximum. Okay. And reads, for reads, you can assign you can give API keys. You can have different permissions who can access reads. And then but you can still have the same Lambda project built as one function. But you can share. You can use the same function in 2 Lambdas, which is infrastructure Lambdas. So they can independently scale, even if it's just one code. That's one of the problems I had with Quarkus, for example. I thought that the first time I saw Quarkus, when I thought.
Wait a second. We can do this still with my projects, because the Lambda is integrated right now with a proxy integration. So it means and we have, I don't know, maybe 30 different JAX-RS endpoints inside with different URIs, but you can still an API gateway say, this endpoint is secured that way, and you have here, this is no difference, and the API gateway will, hit this, or the request will hit the API gateway, and whether this is 1 Lambda or 2, it doesn't matter. But I will get this, but different. So for this Lambda, it works beautifully. So we have only one release. We don't like to have multiple zips and care about, the aliases and versions. We only would like to have one kind of microservice. And the alternative would be an ECS Fargate. So say if this is, I suspected it won't work so far, so great. So I would create an Fargate, but it works fine. But if we write to S3, now what happens is S3 emits an event, and we will subscribe another Lambda. And this is what you mentioned right now. But this Lambda is going to be completely asynchronous. It doesn't have to be even Quarkus. It is plain Java 17. So we use Java 17 layer, so you can run Java 17 right now. And then it will pick the data and write an index and do some stuff. But this is completely asynchronous Lambda. And these Lambdas will be part of the entire application with CDK. And what I'm just saying with Java Power is we can actually build huge Lambdas, and they are still extremely fast. and very well maintainable. It was going to be harder to do the same with scripting languages. I cannot even imagine, to write with JavaScript 300 endpoints, because what I saw, I took a look at the examples from Lambda and what they are doing in Lambdas. They are switching, between HTTP post, put, delete, and whatever. They're implementing their own servlets inside. And what Quarkus does for you, it looks like JAX-RS. So there's no difference. So Quarkus actually picks the HTTP API event from the load balancer, from HTTP API gateway or REST API, then reads that without using reflection, invokes JAX-RS, which is very fast. And I have my dependency injection.
It starts netty. It starts actually the Lambda environment starts a small netty server which delivers this REST. I think that for listeners, it would be interesting to understand, like, why is it like? I mean, I'm saying some good things about AWS, but why is it like that AWS is doing it in a good way? Like, so the thing is, when AWS does serverless, they do this a bit differently. Like, they have they created like a special virtual machine called Firecracker. Okay. So it's a super fast, super slim, super easy, and also they're running it on special machines where they did something which is like a super new, like in this industry. So they separated like networking, security, and other stuff in a small like box which is inside the server. So like you have a Dell server, whatever, inside the network center, but that server provides only CPU and storage and stuff like that. But then, like, the component that does security, that does like access to the network and stuff like that, it's not on that server. It's actually like a special card or something which is outside of that box. So you can switch. You can still have that same management card, but different hardware inside it. So you can have ARM, you can have like AMD, you can have Intel stuff, whatever, but that management thing that's connecting it to the network is outside of it. So what they get also from that is that there's a smaller overhead because the virtualization is not done on that server. It's actually done on that like these things which are shared, like on lower level, are done on that card. Okay, so they really did everything they could to make this thing fast, That's why you can have a server with Java and stuff running in 3 seconds, like in the whole environment. Like you can have a 10 gig server, Lambda, starting in a couple of seconds. So that's amazing, You don't get that. And you see, when you have this virtual machine, and it starts in a couple of seconds, then why is it important? A couple of seconds, because the perspective of a user who is waiting from a response from a website, it's a couple of seconds. If it's longer than a couple of seconds, then I won't wait for that. So then I need something which is running all the time. But if it's lower than a couple of seconds, I can have a front end facing website built on Lambda. That's amazing. You don't have, it's not just for backend work. It's also from anything like that needs a quick response. So that was really important, that breaking that barrier of couple of seconds, going lower and lower and lower. And when you look at what others are doing, they don't see serverless as something that's like a mainstream already, because they're running it in Kubernetes.
Yeah.
Like Microsoft is running it in Kubernetes. Virtual machines in Kubernetes running functions. I mean, you see the overhead is extreme.
Yeah,
like that's the problem.
Yeah, but AWS started in I think 2006, right? And the others, they waited how long? 5 years at least.
I mean, there's a lot of smart people around, but the whole strategy is important. Yeah. Is it a primary thing, or we are just following AWS so we can say, oh, we have that technology too.
Exactly. But important to also very important, there's a misconception that the AWS Lambda, this cold start, how it's called, the 3 seconds, they happened the very first time. And if the application is accessed frequently, maybe they will never happen again. If your application is accessed infrequently, so I would say if you have one request per hour, which can happen is that every request gets a cold start. But what I did actually recently, I delivered a keynote for Vox Bucharest, and actually on stage, on remote stage, I said, okay, if you don't like to have cold starts, so how expensive is provisioned concurrency? And even if you provision concurrency means you can run, you can say tell Amazon, keep your defunction warm. Whatever they do, it should be warm. And it was like, I don't know, between 10 and 20 euros a month. So what it means is we can now with Java run a huge microservice without any cold starts for 20 euros overhead a month.
But look, it's just for the first call,
Yeah.
Because you have one function waiting for you there. But if there's two calls in parallel, then another one will also have a cold start.
Yeah, you're right. But this is the
Honestly,
difference.
I hate it.
Yeah.
I just hate it. That means that you didn't develop your code properly. You didn't split all the things properly. Okay, you're maybe doing some like super crazy PDF image manipulation, other stuff, which really requires more resources. So then the cold start really doesn't matter. But if you are doing something for front end and it takes so much time to start, then you did something really wrong. Okay.
But what we do for front end maybe is a misconception. We are storing the web components and static assets in S3 website. So there is no latency at all. And what takes longer is the REST API call. So this is the Lambda. So
you have to cut it, there are ways to cut it, of course. Quarkus did amazing thing, Micronaut did amazing thing, but with the GraalVM, we jumped to a completely new era, now we can think about, also when you say 3 seconds, it's not like something that like well defined. Like we should say it really depends on what you're doing in your Lambda. Let me give you one of the things that really made my brain explode when I was listening about some presentations about GraalVM, when they were talking about JDBC, and the libraries in JDBC. So JDBC still has user interface done in AWT. What was that called? Remember that that technology, like for front end stuff, like
because it can ask you for username and password, right? There's a mode exactly.
Yes, the code is still there. Okay, so the problem is how much time does it take for a JDBC driver to start? How much overhead it does to our system? So we need to clean our code. Because someone said, oh, I need that in my application. And developers said, oh, let's add it. So like any library, after 15 years, becomes so fat that it doesn't make any sense anymore, especially in the serverless world where there's no interaction. So the problem is like, if you call any service from your Lambda, and you must call some service, okay? You need to interact with someone there. So you can interact with a JDBC, okay? So you are interacting with a backend service. You need to open a connection. That connection, you need to load the driver, do all the stuff, check that AWT, maybe some other classes, load all the classes, billions of classes, and then your service will start connecting and then things will happen. So it's like 3 seconds. It's not just the start, the time for Lambda to start. It's also like the initializing services. Okay, so the problem is it's not just JDBC. HTTP client needs to be smarter. So everyone is now like AWS has its own HTTP client. So we need improvements on the HTTP side now. Someone is using. Many people are actually using OK HTTP also on Lambdas. Because when you look at all the things that start in that time till you connect to DynamoDB or any other AWS service, it still takes time to initialize the HTTP and connection. Okay, so the difference is just for listeners, all AWS services, let's say native services, are accessible via HTTP. So you need a client to connect. Okay, so the problem is like when you do compilation with Quarkus, but I mean Java version. Okay, it doesn't do the tree shaking for your code. Okay. So everything is still there. it will compile in a way that it will try to not use reflection, okay? And it really helps. Many of these extensions really help that the code can just use what it needs, But it's still, the code is still there. Like your Lambda can be really fat, like 30, 40 megabytes. It costs you in some way. Like if you have a big zip with Lambda code, it will take more time for it to start than the one with local.
But this is in Amazon. This is extremely fast. So my observation was the code size of the zip.
It's not enough, Adam. Don't be satisfied with what.
No, I'm not satisfied. But I think I was surprised.
It can be better.
Yeah, sure.
Okay, I agree. So with GraalVM, they actually do the tree shaking.
Yeah.
So that's why this code is like smaller and better, But the small problem is like what I was expecting from people creating GraalVM with Quarkus is like if I have two entry points, like two lambdas in my project, that for when they compile one lambda, that they will just do a tree shake for that one, and then for the second lambda in the same project, they could do the tree shaking for its path, to understand. I mean, when I say tree shaking, I mean if my REST endpoint is using MySQL, then in this lambda, just take the JDBC driver with it and just take the part of it what you need. And if there is another endpoint in my project, in the same project, I'm saying, well, if you compile it, then don't use the driver, okay? But unfortunately, they don't do that, and still in even in GraalVM project, when you build it, you get all the code. So that's a one thing. If you're doing serverless, and what you explained to me, your example is that actually all the things are still in the same project.
Yeah.
Okay. So whatever you add to that project, it will end up in Lambda.
Yeah.
So if you want to do something really small and super fast, you won't be able to have a small Lambda just because the other part of the project is using something else. So
but what we are doing, you know me already. So I say, okay, we do at the beginning the worst possible thing, which is simple. We just implement and we measure entire time. So we have no system tests from the beginning and we measure the performance. And what surprised me, it is fast enough. This was actually the point. I wanted actually to split it up, and I thought, okay, do we have to really to do it? And the outcome is no. So for a mid-range microservice, and we have S3, and with JDBC, what I would do is I would just instantiate per Lambda 1 connection, do it statically without connection pool, and then experiment with RDS proxy, for instance. So to have a connection pooling on the RDS. On the RDS part. But actually in serverless, I try to avoid even relational databases and go straight to DynamoDB. And the reason is not necessarily JDBC or the size of the entire thing, but if I have, DynamoDB, as you already mentioned, I have, one client which talks to HTTP via HTTP, which I don't care first, but what I can also do, I can just say, give me a table. And I have the table. So there is no provisioning. I don't have to decide multi-AZ or not. And it just runs. This is actually the Java E idea applied to a database.
Yes.
It's like, okay, I just would like to have a table. And then what's important for me is at the end of, this is the difference to you. I don't have my own business, but I can show the AWS bill to my client and say, look, this is what we paid for the database because this table was accessed a lot and this was not accessed at all. And now it is his decision whether the table or the data in the table is important or not. And maybe we will even use DynamoDB in current project, but we are very happy with S3 actually right now. Let's see what happens. Yeah. But the point is, what I'm going with it, so we can have larger Lambda functions, which are crazy fast, and with Maven and CDK, we can have a really good modules. So I can have, for instance, what I started already to do is to reuse parts, right, of the infrastructure. With the CDK, I have a construct for a VPC with a VPN, for instance. I have a construct for Lambda with HTTP API gateway or REST. This is already done. So I have a construct where Lambda talks to S3. So, and this is actually identical because this is AWS API. It doesn't change. It will probably never change in the next years because it never changed in the past. So what it means is with Java and Maven, we can create, a reusable part, what you mentioned right now. If you figure it out, you can say, I have now my Lambda module with MySQL and Quarkus, and create a construct, and the developer just says, give me this, and passes, the amount of RAM or whatever, and can even compose this thing with the remaining part. So you can have, you can ask the S3 bucket where the website is called website S3 bucket, where for the URL, and eject this URL to Quarkus and whatever. You can combine all the things. And
yes. You can have like a library of your components, like which are on a higher level than those which are created by AWS natively.
Exactly.
And you can add your own logic. You can even change what's going on behind. You can use something called code artifact in AWS. It's a repo for it's a npm, Maven, other repos. So you don't have to go outside the AWS, and it will cache stuff from Maven, but also you can publish your local stuff to that your own code artifact. So it's even faster. It is local, and then also, like these things that are outside of AWS are not that stable, like GitHub or Maven repos and stuff. So when you have things locally available, whatever happens outside of your world, you still can compile your own system. There's also like Git.
By the way, but because you say not stable, so I played with the EC2 machine, and I had to download, I think, even GraalVM, and it's just crazy how fast the internet is, right? I thought it doesn't work. I was like, curl, whatever, and it was there. It's like, why the connection doesn't work? It was already downloaded. So if you remain in the network, in the region, then it's really, really fast.
If you have like many components which you rely upon, and like if you're using something from Docker, from outside of,
Yeah, outside is problematic, yeah.
Yeah, but the thing is now you can use AWS's repository
ECR
that can proxy.
Yeah.
Yes, ECR. So it can proxy to Docker. So you don't have to and also you don't have a problem with the Docker anymore, like with this limiting and stuff like that. So so you should always use a proxy. I mean, whoever does that in Kubernetes, the people always have local proxies with to get stuff from outside. So you can if something is wrong, if internet is down and anything, like you can actually locally you can still build with your last version and stuff like that. So, but one thing that you mentioned, I need to clarify to people, like something like when I said it's hard, I say that because I have some legacy. If you start a new project, then it should be easy.
Yeah.
But what we see now is that people are thinking about the cloud, and they think about their existing applications. So how would I move my application to the cloud? And that's not easy. Because in many cases, people have a big database behind, and then a lot of microservices. It's sometimes people split their databases, but splitting databases has a lot of implications, like costs and stuff like that.
This is crazy.
It's easy to it's easy to split the application side, but the database and to be like domain. If you need to circle that domain, it's hard, So in many cases, people have a big database, and then they access it from many different microservices. It's a problem. You have to decide one day. Okay, I need to split this. Splitting MySQL or Postgre to different databases will cost you also. Like it's not like you need to provision another server. Like or if you do that in Aurora or stuff. But anyway, like every single instance costs you like a fixed price, So why DynamoDB is good is like when you provision it, it doesn't cost you anything if you don't use it. Like you pay for use. Like if someone, just imagine that someone is charging you per for your Postgre or MySQL per use. Okay, if you don't use that part, that if you never access that table, you will pay almost zero just for the storage.
That's true, yeah.
So
I'm storing right now actually stats from my podcast, and I don't pay anything for DynamoDB. So I'm below, the...
Perfect, yes, perfect. Yes. So the other thing with AWS also is like the idea that they promote is that one database is not enough anymore. Okay.
By the way,
you
database.
Should have different.
Because we're talking about cost. So I did the calculations for multiple clients, and even a mid-range database, a smaller one, will cost you roughly 800 euros a month. So if you're using a database with a license like MySQL Server, it will be 1,000 euro more. But if you use something like MySQL RDS, they are very equal. Of I don't know, 2-4 CPU machine with a little bit of RAM, you will pay roughly 700 to 1,000 euros.
You can cut costs in AWS
in advance
by buying stuff in advance. You can get like 65-70% if you buy 3 years in advance. If you just commit, you'll also get like 60%. Okay, for 3 years. So, but the problem is like, can you see yourself in like 3 years? Do you see this traffic, this amount of usage will be there in 3 years? Maybe you would need more, maybe you need less, stuff like that. So, but the problem is like, sorry.
Wait a second, because two additional interesting use cases, what you maybe like or not. So one is another project is legacy project. And it's a great project, actually. It was Whitefly. They were on OpenShift, and they had a couple of microservices. And now they have to go to the cloud because of security and disaster recovery and stuff like this. So they have reasons to do that. And I helped them a little bit. And what we did there, we just installed or provisioned AWS Fargate. So, okay, Fargate seems right. And the interesting part is, so we will have to buy the database. There's no way to migrate away because they need a database.
Yeah.
The question is, what do you do with the microservices? And what we did is, okay, we will provision one Fargate cluster. And then what if we buy the largest one? So what does it cost? A largest Fargate cluster means 4 CPUs and I think 32 gigs of RAM, costs roughly 200 euros a month. So maybe more or less, but something which is already interesting because Kubernetes costs you 100 euro just for the control plane. I mean, and we have the entire time running.
About it.
Yeah, this is Your
brain needs to be there.
Yeah,
and
they were on Whitefly, and I said, okay, this is one app on Fargate. We can only scale up to 4 CPUs and 32 gigs of RAM. So, what if we ship a monolith? Because it doesn't make any sense to have 5 microservices.
Exactly.
And what we did as proof of concept, one Whitefly, and we pack all the microservices which are distributed to one machine on 5 wars on a Whitefly, and it worked. And so look, I know the shipment is easier. You shipped always the same version in 5 microservices, so you never had the necessity to replace one single microservice. So you just did it because it was fashionable. So there was nothing behind, and everything became simpler. Now we have one CDK project with the microservice. We have one port, one load balancer, and it already runs. And what happens now?
There is a term called like. Sorry, there's a term. I need to interrupt you now because there's a term called lambda monolith. Okay.
Yeah.
That's something that you at the beginning of this talk you said you have all the calls on all REST endpoints in one lambda. Okay, but it's a lambda monolith, but it's just like a code is single, but you can still deploy it in a different context. You can use it in one context as an asynchronous call, and another context is a REST endpoint for this or stuff. But it can still be one code, and you don't have to split it. That's a good thing. That's a good for migration, but still, I would say as a first step.
As a first step,
because
and now what do you do? You say, okay, Whitefly, we will have to move away from Whitefly. They ask me why. It's like, yeah, because if you look at Red Hat, I would say most of the developers are really excited about Quarkus. I mean, there is there's a Whitefly team, but the majority works on Quarkus. I would say Quarkus is now extremely popular. So and Quarkus comes with some features which Whitefly doesn't have, and they say, okay, interesting. So what we can do about that? Should we migrate to Quarkus? Like, no. If we now migrate somewhere, then to Lambda. So what we can do right now, we can look at the monolith and say, okay, this microservice could be, completely extracted from the Fargate and implemented independently as Lambda.
Yes.
And the cool story is
the Fargate cold start for Fargate with Quarkus. it's about 30 seconds, like 35, 34 seconds. It's amazing. You can still run it in Fargate, but it will run faster. It will not we saw incredible improvements when it switched from OpenLiberty to Quarkus running in Fargate.
Mm-hmm.
That thing is like one scale. That's just faster,
but if the Fargate task runs all the time, it runs all the time. So the idea is we will run all the time.
Yeah.
So there will be it will start once and there will be no shutdown. It will run entire time. So the idea is we buy the largest Fargate instance and run it all the time. So there is no scale down, scale up. We pay, the maximum, which is 200 euros a month for one task. And one task is one monolith. The interesting part is, now we can extract the Lambda, but this comes later. But there are already some microservices which can do this. So we can extract it. And now it comes. We can even use the same load balancer now. And this load balancer can balance the load between Fargate and Lambda. So it means it will never change for the clients. And we can move, more and more workloads to Lambdas. And this
you can split, even in production now. You can have a situation where it's good for you. So during the day, you run stuff in Fargate.
Mm-hmm.
And during the night, when you have less calls, you can run it in Lambda.
Yeah.
So the load balancer can switch between them, like depending on the time of day. So the same code can run in both environments.
And I suspect you are using AWS Lambda with how it's called, Event Bridge, to tell the load balancer when is night and when is day.
I mean, different. Sometimes some like basic stuff can we use code deploy with a scheduler to do some calls and just switch something in infrastructure. So that's something that works for us.
Are you actually using code deploy with the blue-green deployments?
Yes, but it's It really depends, sometimes it makes sense, but integration tests are not something that we are really super I'm not happy with the level of test coverage in my system. So sometimes, it's there, but in most cases we don't have enough tests.
But you attended the AirHacks workshops in Munich 5 years ago, and it's still no progress.
We didn't listen to that part. I mean, we're just waiting for stuff. Maybe that was a coffee break or something.
Okay.
But the problem is that the testing needs to be different. Quarkus testing is something really interesting. People should really dive in, and the integration test with Quarkus should be people should do that. But I don't know what's your test coverage, especially with integration tests. But
I have no integration tests. I have a couple of unit tests where it's complex. And I have pretty good coverage with system tests where you call the Lambda from outside. And one tip, what I'm doing, we have the JAX-RS endpoints. We are copying the JAX-RS endpoints to the system tests and modify them to be interfaces. And now we use microprofile REST client and inject these interfaces to Quarkus test, to an unit test, which is annotated with Quarkus test and IT. And with the base URI, is localhost 8080.
Yes, exactly.
But the cool story is the base URI is overridden in code pipeline with the real thing, because the code pipeline knows what the real thing is. So we run the same system tests on the code pipeline, which is fairly easy. There's only one env entry, and we can override this. And this works actually surprisingly well. And every push starts the code pipeline. That's what happens.
The problem with the blue-green is that I hate that it takes so much time.
Yeah, exactly.
For one deployment to get. So what happens if you just deployed something and then you see, there is a mistake?
Yeah.
Oh, I have to change something, So then you commit, push, and then you wait.
Mm-hmm.
And then if you have to wait 15, 20 minutes, you are done. Okay. Your brain will explode waiting with client calls. So one good thing is, although it's not something that is something that you should do. They don't say that. They especially say that you shouldn't do that. But if you have a project with a CDK that you use in CDK pipeline, okay, you can always do something which is called hot swap.
Mm-hmm.
Okay, you can make a build locally and call the same code with the CDK infrastructure, and it will just switch that code in production for that one thing. Okay, maybe till your code pipeline does everything in the background, you can do that and like switch one function.
But this is new.
Just switch one.
This came last year, I think, right? With the CDK.
Yeah, the AWS last year, and it's actually not something that is completely new thing. You can always call an API and switch the code for one function, but the good thing is that you can do that for the infrastructure and say, okay, I have everything changed locally. Can you just deploy this, and it will just find what it has to change, and then it will deploy it. Okay, so the thing that we were talking was like, it's for if you're starting now, you should think about cloud native in a way. What's really, let's just avoid dependencies to old technologies. Like Kubernetes is old technology.
Yeah. And cloud native, the entire discussion with cloud native, I never got it because we always were cloud enabled. And, if you look at how it's called, the old rule, how is this? 12 factor apps, right? 12 factor, 12 factor? Yeah. If you read this, every Java application is 12 factor app. And there was a huge, talks about cloud natives. Like, what are you talking about? Because if you package this in Docker container, a Java EE application server, it is 12-factor app if you do it correctly, right? If you not read, your configuration from XML, but from environment, which you get per default with microprofile, then you are cloud native. But maybe we need another term. So what also you mentioned this already. You should use managed services. I mean, whatever the cloud built, which is proprietary actually, which we are afraid for years. But for me, this AWS, if I'm running on AWS, is the new Java EE. I'm running in the environment anyway, right? It's not like I cannot just say I would like to be independent from the operating system of running on the operating system. I mean, a little dependency is okay. So, and now, if I would use messaging, right, instead of installing or provisioning my own JMS server, I would use SQS and SNS. Why? Or Kinesis. Why? Because I get, the libraries. It is natively integrated with HTTP, and I just say, give me a queue, and I have a queue. I don't need the queue anymore. I don't have the queue. Yes. So it is very fast. So I don't know how to call it. I would say, if you would like to be cloud native, what it actually means is use, the built-in services and don't try to abstract from the cloud. Because if you abstract
it's real serverless. When people say serverless, they mean Lambda in most cases. But the real serverless is like managed services.
Yeah, exactly. Managed services.
Especially if they can scale to zero, so you don't pay if you don't use it. That's serverless. That's mostly the definition of serverless.
Yeah.
When you look at the services,
one very important part, Goran, which I have to mention because I forgot it already 3 times during the talk. The great story is for serverless is the developer experience. So in my current project, we have 4 developers. We're a smaller team, and maybe 8 accounts. Let's see, 4 developers plus dev, int, and prod, and the code pipeline. This, I think, 8 accounts, and of course the master accounts, which doesn't matter, and reporting or whatever. So the cool story is with serverless, every developer can have his or her own environment. Because it's not a big deal, in my account, provision, DynamoDB, whatever I need, the entire stack belongs to me. And I pay nothing for development.
Yeah, exactly.
Yeah, try it with Kubernetes. So for me, I still don't get it. So what are you doing? Every developer gets an own Kubernetes installation in the AWS account, or they're using a shared Kubernetes and hope it behaves.
Or they can install it locally on their machine, on their PCs.
Yeah, but this is everything but not cloud native. If you install your Kubernetes on your machine, this is what they did 20 years ago. So what I'm talking with now, we have the unique opportunity to use the entire time the real thing. If you have internet connection, you can use actually the entire time in your account, your production environment, which happens to be your environment. And you can have the entire stack. So in new applications, right? If you have legacy, shared database is harder. But the new is another problem. I can create, a DynamoDB table, delete the table, create the table. A little bit harder is 3 buckets because they have the globally unique names. So a little bit fiddling, but I mean, you figure it out.
Every developer can have its it can have its own account, so it doesn't
exactly.
matter.
So and delete these S3 buckets. You have to empty them, but these are small things like security measures.
There is like in CDK now, you can have a
policy
switch that says
but it installs a Python Lambda. If you do this, I think it installs Python Lambda.
Yes. Just this is it's not that everything is like perfect in this world of
which I don't like the Python Lambda. I have to
AWS and CDK and stuff. The thing is like people who should not really rely on that. Everything will be managed by someone else, and they will do everything in my best interest, and they will scale automatically, do everything perfectly. You still have to learn about what's going on. That this example of where you create a bucket like storage on AWS, and then you want to destroy a resource. By default, you cannot destroy a bucket if there's something inside. Mm-hmm. Okay, so the CDK, which is like an entire framework for itself, does something extra for us. Mm-hmm. It actually creates a small Lambda function and deploys it in your account. Mm-hmm. So in a moment, if you in CDK, if you set the switch, okay, you can delete this one entirely, even if there is something in. It will add to the functionality of AWS. So when the delete of the bucket starts, it will call the function which will do the delete, and then kill the bucket. Okay. Mm-hmm. So what's wrong with this?
No. So what's wrong is AWS should hide this.
Yeah, yes, exactly.
This shouldn't be visible in my account, because I did it the first time and I said, what's going on? What is this? And I look at the source code of the Python and I say, okay, they are deleting this. But for me, it was not evident.
Adam, you're doing Python.
This was. One question to you. Are you running your AWS Fargate the entire time, right? You are starting this at day and then shutting it down.
No, not different. It's mostly auto scale. First of all, I run all these things on spot instances. Okay, so it's like 90% cheaper.
Yeah,
but they're never out of instances, so I'm completely fine with that. Okay, I never had any problem. So that's first the thing that is cheaper. Then you can set auto scaling for Fargate. Okay, so for example, when you generate pixel perfect reports, like if you use BERT, do you use BERT?
I used back then. I used BERT a lot.
Eclipse, BERT, okay, we still use it. Okay, so if you want a pixel perfect report, then one client initiates a creation of a new report. Then, since the 30 seconds is only it's the time for a cold start for a new Quarkus in a new Fargate instance, we just push it to SQS. And then there is a monitoring of on Fargate how many messages are there in SQS. If there's another message that we didn't process, it can start a new Fargate in 30 seconds and run it. Well, that also changed because now we run lambdas, 10 gig lambdas.
Exactly.
And it runs build in 3 seconds. It's done. Yeah. So it's super crazy, and I don't care if it's still running there. I'm just paying for my 3 seconds. So,
but you are storing Fargate, the report in EFS, right? I guess
we are saving it back to S3.
Okay, S3. Okay.
We don't use too much. Mm-hmm. Yeah, we don't use EFS too much.
No, you're right. EFS, S3 is way better. I just thought that this is your legacy system, but S3 is even better, of course.
I'm saying so. Like Fargate, we need. For these parts of the system where we have like front-end facing Fargates.
To Goran, I have to invite you back. Just talk about this now, about your system if you can. Because we will spend 1 hour, because it's interesting. I wanted to ask you about Lambda destinations right now. And I would say, if I ask you this question, we will spend 1 other hour just talking, because this is the cool...
It's a messaging, asynchronous stuff. That's something that's really cloud native, and it's a completely new topic.
Yeah, okay, exactly. Because the serverless works only well with events, and the Quarkus is what I do right now is like misusing the entire concept, because this is the only exception when the event is synchronous, right? Because the API gateway sends the event and blocks and waits until the Lambda returns. Your use case is actually better for the reports. And now I understand why you have the cold start in Fargate, because in my Fargate's examples, the Fargate runs all the time, so there is no cold start, except if you ship a new version, and the cold start means it is not available until there's never cold start, because it won't be visible until the readiness probe hits, and then it gets traffic from the load balancer. So it's always fast.
Yes,
but you could also use Fargate as called schedule task. So for batch processing. So we're also using this. Exactly. So this is perfect. Okay. So where people can find you and how they book, your services from your company. What's the name of the company? And if someone would like to have a Starbucks app.
Yeah, it's it's called Este, but I mean, it doesn't really matter to people who are not in business. Like it's for developers, it's just like they don't care about too much what's really going on in the market. So I have this kind of I really like the business part of it, So mostly developers don't really care about what's it, but I really like that part, and I want my software to do something really useful. Okay, so I mean, my company is called Estech, but it really doesn't matter. I really like to talk with people about technology, so they can check me on Twitter. It's Goran Opacic, Goran Goran Opacic. So that's my first place for discussion. So yeah, I'm also a AWS data hero. So if you have any questions about databases in AWS, whatever database, I like MySQL, but any questions, let's just feel free. It's hard for Java developers to switch to a new world where there is no some MySQL or Postgre in the background.
Okay,
and it's like
then we need
even that running.
We need 2 days.
So,
the first one we will talk about serverless and events, and the next one about databases.
Yeah.
So the next one we should do in a few weeks, and then maybe in autumn or winter another one just about databases.
Yeah, we can run one if you the Java one is coming. So maybe if you are coming to Las Vegas this year, I mean, I really like Java one coming back to the world. So
this is a great,
I'm definitely going to be there. So we can record one episode there.
But with terrible sound, maybe about this authentic, that the people.
Of course.
Perfect. Thank you.
Great. Thanks, Adam.